All right, so we left off with part B on the spring oscillation problem, and we're just going to continue with it. So this question is asking when the spring is compressed and when it's stretched, and we're going to find those time intervals over 2 cycles. So to understand this problem, we first need to know what's happening to the function when it's compressed and when it's stretched, when the spring is, I should say. So they tell us in the diagram that if you pull the spring down, if you stretch it, the function is greater than 0. And if you compress it, it's going to be less than 0. And we're going to use that information to help us solve the problem. So for stretched, h of t is greater than 0. And then we're going to just write in our function. If you see me looking to the side, I'm just looking at the answer key, so nothing weird happening. All right, so that's our h of t function. And the 0.5 is not really going to matter because it's, you can divide both sides by 0.5 and it's just not going to affect it. So we can kind of just get rid of it. And so we're left with sine of 6 pi of t, sine of 6 pi times t, that's better. And that's going to be greater than 0. At this point, it looks pretty complicated, but there is a way to solve it. So let's make our lives easier and say that x, some variable, so x is equal to 6 pi t. And so what that's going to allow us to do is find an interval for this inequality, and then we can substitute the t expression back in and actually solve for t. And you'll see what I mean in a second. So if x equals all of that, then that means wrong color. It's very important that the color is right. So sine of x needs to be greater than 0. And then at this point, we're just trying to ask ourselves, where is sine positive? And that's going to be between 0 and pi. Okay, so at this point, we're going to put the t back in. So I can actually just erase it, and let's write in our t equation instead. So 6 pi t. And then to get t by itself, we're going to divide everything by 6 pi. And so we know that t is in between 0 and 1/6. Okay. And we're finding the time interval over 2 cycles. So let's think about that for a minute. We know that 1 cycle is 1/3 of a second, which means that 2 cycles, do a crazy arrow, is going to be equal to 2/3 seconds. So we just kind of have to keep that in mind as we keep working out this problem, and make sure that we have solutions for t in either column that kind of fills up that 2/3 time interval. So let's go ahead and work with compressed as well. It's going to be the exact same process, except the function is less than 0 now. I think that's what it said. Yeah. Be kind of bad if it didn't say that. And we're going to rewrite the function here. I'm going to go ahead and do a shortcut and get us down to the sine of x portion. So where is sine of x less than 0? X is going to be in between pi and 2 pi, if you look at the unit circle. Okay, let's go ahead and replace our x with the expression that has t in it. So we can solve for t. Again, we're going to divide everything by 6 pi. And we find that, okay, I'll do that in blue. T is going to be in between 1/6 and 1/3. Okay, so we're almost done, but that doesn't really answer the question fully because we're doing this over 2 cycles, and right now we only have between 0 and 1/3 second. And so here's what you do in this situation. I just want to point out it's because of the 6 pi. When you have that sort of coefficient and you end up dividing by it, it kind of makes your intervals smaller, so then you have to keep adding them on until you fill up the interval in the question. So let's go back to this right here. So we had x, we replaced it, but before we had x was between 0 and pi. And so what we want to do is add on 2 pi to both parts of those intervals. And that's just going to give us another cycle, which is what we're looking for. So if we add 2 pi to both sides, x is going to be between 2 pi and 3 pi. And then at this point, we can replace it with t. So 2 pi, 6 pi t, 3 pi. Divide everything. T is going to be in between, what is it? 1/3 and 1/2. So let me keep this separated. So then we got to do it again on the other side. I guess I'll do red. So originally we had x was between pi and 2 pi. X is now going to be between 3 pi, and then add 2 again, and 4 pi. Okay, and then I'm just going to spoil it. You would plug t in and then divide everything by 6 pi, and you're going to be left with t being between 1/2 and 2/3, which is what we're looking for. So now we have all the intervals between 0 and 2/3 where the spring is stretched and compressed. Okay, that took a while, so we'll do part C in another video.